Good morning. So I'm going to go through these two questions that you've asked me to do, Mary. Um, Start on the left, and then we'll look at the one on the right, so I'll zoom in a bit on this. So, this first one, um, these are kind of probably my favourite type of questions, because they're a bit of a puzzle about the best way to go about them. But when we see an e, and x as to the powers of, we need to be thinking of doing logs, or if it's e, lun, which is the natural log, and that basically means log to the base of e. What you most commonly see is log base 10. That's kind of how our number system works, because it's got 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go to the next lot of 10. So I'm going to take the natural log of everything I have. If I've got to take it all of this together, I can't just split it up and do the natural log of 3 to the power of x and the times by the natural log of e to the power of 4x minus 1. It's got to be done all together. So it's important to kind of organise, if it's not put in this format, it's organised to get all your powers and stuff on one side and then all your numbers on another side. So when you do take logs, it's possible to work with and you don't just get tangled up and back to square one. We've got a law of logs where if log ab, so that means a times b, we can split that into being log a plus log b. So I'm going to use that law here, and I'm going to split this like that. So I've just used this law down here. Give yourself a little quick pause and a look at that if you need to familiarise yourself with that. When we get something like this, where we're doing a lun of e, because it's the log base e, and there's e up here as well, so this would look like this. I'm not going to go into the whole reasoning of this, but logs and e's are inverses of each other. So if you lun natural log and e, they kind of both just disappear, and we just get left with what's on the top. So that's my next step. So now I kind of want to do it like solving an equation. I'm able to get rid of this minus 1 now, so I'll have just x's over here. So I've just added 1 to both sides. There we go. And then our second law of logs, I'll put these in a little bubble. Our second law of logs is if we have log, this also works with luns by the way, I'm just writing log because it's more commonly seen. If we have something like this, so something to the power of something, so we've got 3 to the power of x here, we can take that power and put it at the front. So going from that law, I'm going to write x lun of 3, and then I'm going to continue with everything else I've got. It's best to just do this step by step. Like, I feel like I could have done this in about 3 lines of working, but I'm doing it in about 7 or 8 just to make sure I do everything individually and not make any mistakes. So final step to get x on its own. We've got some weird luns here, but if you had other stuff there, it wouldn't look as confusing. I'm just going to factorise out x. So x, lots of lun 3 plus 4. So I've taken an x out of these two terms on the left, and then I'm just going to divide, because that's going to get me x on its own. So lun 5 plus 1 all over lun 3 plus 4. And that is just a number, but we're going to leave it like that. Just like when we work with square root numbers, like root 7, we're not going to convert it into a really horrible decimal. We're just going to leave it like this, because we know what it means and it makes sense. So important, just them two rules on the left. And just to complete that, we didn't use it, but if we have a over b, so log of a over b, we can write that as log a subtract log b. I'm pretty sure they are our three laws, and let's say we've got ln of e to the power of n, we can just write that as n. That's what I did on this step here. My n would have been 4x minus 1. So that's the I used 3 of them 4 rules. Okay, this question here, this actually caused me a few problems because I thought it was going to be a lot harder than it actually was. I managed to get there, but through a really complicated step, and I realised it was far easier. So basically, if you we've been given this, and I think this was linked to y equals ax to the power of n, and then they've took log of x and log of y, so this one would be linked to something like log y equals to log a log, I'm not sure. I'll skip that step. We don't need to know that anyway. Let me fill this back in. That was 1/8. Okay, so basically all they've done for this step is if you take log 3, you will get 0.47771. And what they've done is they've rounded that to 0.48 and they've chucked it there. If you take log of 16.3, you get 1.212187, so on, and they've just rounded that to 1.21 and they've chucked it there. And if you do log of 15, you get 1.18, and if you do log of 155.1, you get 2.19. So basically all we're wanting to do for this question is to take log of 33.3 and chuck our answer down here. Log of 64.3, chuck our answer down here. And log of 87.9 and chuck our answer down here. So our 3 answers for these are 1.52, these are all rounded to 2 decimal places like they asked me to, 1.81 and 1.94. So it's log y, we've been given a value of y, and we just need to, it's just to calculate a job at that stage. Okay, the next part was asking us to draw the graph, wasn't it? So I'm not going to struggle to do this on a computer, I've plotted it nicely. So if we go to my GeoGebra file, what I've done here is I've plotted the table of values from the log. So log x was 0.48 and log y was 1.21, so I've plotted that. You can see I've A, B, C, D, E, I've done it in order of the table, you can just double check everything I've done. And it's not a perfect straight line because we've rounded some values, but on a piece of paper you probably get away with that, and it probably will look like a perfect straight line, just a computer is really specific. So this is what it will look like plotted, and I've drawn a line between A and E. And then if we go just quickly to the work solutions, you can see that is pretty much what they're wanting to, so this line here. Make sure you label your axes properly, log x, log y, and use like a appropriate scale, so they've just got a slightly different here and slightly longer on the y because the values increase. They're bigger values, so it just saved from drawing a massive table. Okay, so back to question C. Part C. So we'll leave that there because we might need it. So going back to what I said at the start of this question, this table here is showing, instead of y equals ax to the power of n, so instead of this, it's showing so they've kind of just logged both sides, because that's what you have to do when you log. You can't just pick specific things you want to log. You've got to log both sides, all of everything there. Let's use our rules on this side. So maybe you can figure out how to split this up. Give it a pause if you want to, I don't mind. So we've got a power, yes, but first of all, if this was looking like that, can you see the n is powering a and x? I would then bring it to the front, then I would split it. So I'd have n log a plus n log x. That's what we don't have. So first we need to use our rule where we split them with the multiply. So I'm going to have log a plus log x to the n. If we go ahead and do it this way first, we'll get it wrong. So it's not like that. It would be if everything in the middle was to the power of something, but it's only just the x. So we need to take this step first. Then I leave the first step like it is. Then I can take this power to the front, n log x. I'm just going to write this the other way around. Okay, so the method we're going for in the textbook here is we're comparing this to the equation of a straight line, because we've drawn a straight line, haven't we? Well, pretty much. That points a little bit off because of rounding, but it would be a straight line. So basically, this kind of looks like y equals to mx plus c, and I'm doing it in capital letters, so that shows that it's not actually y equals mx plus c. That's a common thing in maths. So this goes down to here. The m is a bit like the n, the x is like our log x, and the log a is like our c. So when they're asking us to find the value of a, so we're being asked to find n and a. So when we're trying to find n, we're actually trying to find the gradient, because that's what this would be in a y equals mx plus c, wouldn't it? That is the gradient. And when we're asked to find c, well, we're actually being asked to find the y-intercept, because that's what it is in a y equals mx plus c equation. So if I screen cap my graph and bring it on here so I can do a bit of work on it. That will do for the demonstration. So here's my graph. Let's go for A first. I'm going to do that in red. So we need to find this here. Oh, I should have really capped the 0.2 down here. But that's going to be somewhere like this. If we zoom in and everything, on my one, we get that. So we get this value here would be log a, because that is where that is the y-intercept. And on mine it's going to be roughly 0.54. You're looking for something between like 0.54, 0.55-ish. But we're just wanting to find the value of a. To undo, do you know, like I said, the inverse of a ln was e. The inverse of a log, if it doesn't specify a power down here, if it doesn't specify a power, we're doing it log base 10. That's just the normal one, and we don't feel like we need to specify it unless it's anything different. To do the opposite of this, we need to raise everything to the power of 10. Or we need to raise this power with the base 10. So we raise with a base 10. So we'll do 10 to the power of log A equals 10 to the power of 0.54. Again, this and this will cancel each other out because 10 to the power of and log base 10 are inverses of each other, so they will cancel each other out. And then 10 to the power of 0.54. You even have a nice little button on your calculator for that. That gets me 3.467, so on. So 3.47. I might have got it slightly a little bit different from the textbook because I think they were wanting 0.55 with their graph. Yeah, and what they get. So if you do it as 10 to the power of 0.55, you get 3.54. So that's exactly what they were wanting. That could have been what mine looked like if I zoomed in a little bit more. I just didn't. And then the gradient, well, if we go back to here, gradient is just pick 2 points and make a little bit of a triangle. So I can do that here. Let me try that again. So I pick my thing and I pick a point. Okay, here we go. Let's move this. So this just does the gradient for me. And I'm getting 1.14 I think I'm meant to get. I'll do it by hand as well. So basically what we're going to do is just going to pick 2 points. So I'd probably pick the 2 values they give you in the table. They've given us these values in the table that I've circled in green. So to find the gradient, I would do the change in y over the change in x. So my change in log y in this case would be 2.1 subtract 1.21. 2.19 subtract 1.21, and my change in x would be 1.18 subtract 0.48. Reason I'm doing these values is because just in case I got these values wrong, I'll still get this answer correct because I'm not using anything I've figured out. So if I go ahead and do this, that's divided by I get bang on 1.4. So because my gradient is 1.4, that is my value of n. So they are my 2 answers and we've done the working out for them. Okay, hopefully that was helpful for you. Don't know where my stop video button's gone. Here we go. Okay, cheers.